Another couple applications we'll look at is exponential growth or decay. And exponential growth or decay is kind of like your compound interest formula, but notice we're only doing the R here. And if you're growing, R is positive. If it's decaying, R is negative. That's the biggest difference. So we add to 1 if it's growth. We subtract from 1 if it's negative. So my answer in the parentheses will be less than 1 if we're doing decay. And then we have also a formula for continuous exponential growth and decay. So if it's continuously growing or decaying exponentially, then we'll use this formula, where K is going to be your interest rate, your rate of exponential growth or decay. Sorry about that. And it'll be negative if it's decaying. So we take a look at example 14. So what you have to do is just to identify, first off, is it continuous growth or is it just exponential growth? A state's population is declining at a rate of 2.6% annually. Okay, annually tells me that's not continuous then, is it? The state's current population of approximately 11 million people, the population continues to decline at this rate. Predict the population of the state in 15 and 30 years. So here's what we're going to do. We're going to start here. I'm going to answer my answer in millions. So I'm not going to write 6 zeros out. So I'm going to say the population, I'm going to start at 11 million. I'm growing at a rate of 2.6, so that'd be 1 plus 0.026. And we're going to raise that to the 15th power. In other words, it's 11 times 1.026 raised to the 15th power. So we'll use that. And remember, our answer is in millions now. So I'm going to say 11 times 1.026, 1.026. I'm going to raise that to the, sorry, my 6 didn't show up. I'm going to raise that to the 15th power. So I'm going to get about 16 million. So I'm going to say 16,166,019. So 16,166,019 people is what the population would be if, oh, hold it. Sorry about that. It's declining, isn't it? Darn. Well, we got a little practice. So let me erase this. And I want to change this to a minus. Need my pen there. So 1 minus, sorry about that. So we take 1 minus 0.026. I get 0.974. Raise that to the 15th power. Yeah, because we're declining, we should have less people. Sorry about that. So I'm going to change my base here to 0.974. Put it in parentheses just to make sure. 0.9774. Not 2 4s, just 1 4. And I'll close that parenthesis. Okay, so we get about 7 million people. So 7,409,298. So 7,409,000 and what was it? 409,298 about. Now, let's do it for 30 years. So the only thing I'm going to do on 30 years is I'm going to change my exponent to 30, but otherwise it's going to be the same. So n equals 11 times 0.974. Raise that to the 30th power. So we'll do that in the calculator here. And there we have it. So after 11 years, you're going to be under 5 million. Okay? So I'm going to say less than 5 million. And of course, you can write the number out if you want. Let's take a look at example 15 here. It says a state's population is declining at a rate of 2.6% continuous. Oh, the only difference is now it's continuously. So then I want to know, predict the population in 15 and 30 years. So now my formula, the only thing I'm going to do is have a slightly different formula. So it'll be my initial population, n sub dot, times e to the kt. Well, in this problem, since it's declining, my k is negative. So it'll be, I'm going to start with 11 million. I'm going to e, and I'm going to raise that to the negative 0.026. And times 15, because t is 15. So we'll use a calculator for that. So we'll go, let me clear this out. So it'll be 11 times e, and we're going to raise that to negative 0.026. We'll take that times 15. And so we're going to get about a little bit less than 7.5 million. So I'll say 7.4 million. Compare that to not continuously. It's pretty darn close, isn't it? 7, if I want to actually write that number out, let's take a look at that number. So that'd be 7,444,626. So 7,404,626. My brain is slow, so I'm going to double check. 447,626. Now compare that to just the growth. And we have a few more people, don't we? And then let's do it for 30 years. So the only thing that's going to change, and is going to be 30. So it'll be 11 times e to the negative 0.026 times 30. So I'll change my 15 to a 30, and then we'll have our answer. And about 5 million again, isn't it? A little bit more than 5 million, okay? And there we have it.